Hello, I'm Roman. Welcome back to the series of the videos neural networks from scratch in Golang, where we implementing a neural network from the scratch. And to do this, I'm using the book called Neural Networks from Scratch in Python. But again, I'm writing everything with the Golang. And in the previous video, I started to implement loading of the fashionist images, fashionist dataset, which is the replacement for popular NIST image dataset for the learning and for benchmarking of the neural networks. And this one kind of hard to find a neural network that will have a good accuracy comparing to the handwritten digits. So it's pretty easy to implement a neural network that will have 99% of the accuracy. And in the previous video, I started to do data loading. And instead of the OpenCV, I'm using the standard image struct from the Go. And I finished the loading and the conversion into the dense struct. The only thing that is missing is the correct values here. I made a mistake with the division because I need to change the... I'm going to change the ranges of the values from -1 to 1, from 0 to till 255. So I made a mistake here. It was the 255 here. This is why it gave me incorrect value. Also, there is a weird way. I know that the image is grayscale, but the PNG decode returns image, and this image, which one? I think this one, yeah, it returns the color. But the problem with color that it has the RGBA, only this one. And looks like in the grayscale, it returns kind of weird values, or maybe overloaded values. So if you take a look, actually last time I had a problem with the top, and looks like I have right now too. Let's start. So I have I think this one, yes. No, files to launch, okay. No, not this one. And image imported but not used. Where is it? All right. Okay. Then now it should work. And okay, if you take a look, there are -1, so all good. But if we go for a place where there is actually some values, non-zero, you see that the value is 53,000. But if we take a look at what returns image.Image, it's actually image color gray. But if I try to use it, for example, I have the @img, and if I will try to use Y, it tells me that unable to evaluate, has no members. So what I'm thinking, maybe I can downcast image color gray. So I need image color, this one. No, which one? I think, yes. So if gray, oh no, I need gray, okay, equals to image @ij, and how it's like this, color gray. Okay, so if awk. Then I can y equals to gray.y. Okay, and then it means that this one is actually y, right? Let's take a look. Lua require the terminate. No active session. Okay. Why is not started the new one? Lua. I think the dub got updated. I mean the plugins, and it started to behave a little bit weird because, yeah, I cannot start it. And I had the issues with the debugging before, so I had to fix the UI meanwhile. But okay, I will. Maybe there is something with the. Yeah, and I actually have this weird thing. Okay. Maybe this one. Okay. So if we'll take a look. Oops. What do you do? No. We have -1. Okay, so let's go. Oh, okay, so we have some 14. So that looks much better. Okay, so if I will go here, I will disable this one and this. So what do we have here? Can I? Yeah, it's not showing more. Okay, so let's try call data 100 -1. Okay, call data 200. Okay, call data 3. Okay, I assume that adapt debug. Okay, I assume that it's okay. Should I return the error? I think yes. Nil errors new or was new. Cannot take grayscale color. Errors. This one, right? So what do we do? So we have the training dataset, and okay, let's take a look. Define data, right? Maybe I can do this at, I don't know, tense image, or maybe a row tense image. Make run. Yes, I've been changing this. Make file. Okay, those are the labels, and this is the image. Okay. So this is the representation of the image. And like briefly, I can see that it goes from -1. Do I have ones? No, looks like not. -1 is the dark. Okay. So what it means? It means that no, let's do this. It means that I have the data loader, right? Okay. Loading of Versionist dataset. Okay, how long have been recording? 10 minutes. Okay, let's take a look. Data preprocessing, we've done it. The next thing, data shuffle. Our dataset currently consists of the samples and their target classifications in order from 0 to 9. To illustrate, we can query our Y data at various points. Yeah, we took a look at this. Yeah, they all ordered. This is a problem if we train our network with the data in disorder for the same reason. An imbalanced dataset is problematic. While we train on the first 6K samples, the model will learn that the quickest way to reduce loss is to always predict as 0, since it will see several batches of the data with class 0 only. Then between the next like 20%, the loss will initially spike as the labels will change, and the model will be predicting incorrectly, still label 0, and will likely learn that now it needs to always predict class 1, as that's all it sees in the batches of the labels which we optimize for. The model will cycle local minimums following whichever label is currently being repeated over batches and will most likely never find a global minimum. The process will continue until we get through all the samples, repeating however many epochs we selected. Preferably, there would be many classifications, ideally some for each class of sample per fitment to keep the model from becoming biased towards a single class. Simply because that's the class it's been seen lately. Thus, we often will randomly shuffle the data. We didn't need to shuffle our previous training data, like spiral data, since we were training on the entire data sets at once anyway, rather than individual batches. With this larger data set, we are training on in batches. We want to shuffle the data, and it's currently organized in order to have chunks of 6K samples per. When shuffling, we want to ensure that we shuffle the sample and the target arrays the same. Otherwise, we'll have a very confused and very wrong in most cases model, as labels are no longer match the sample. Yes, we cannot simply go shuffle on both of them separately. There are many ways to achieve it, but what we will do is to gather all of the keys which are the same for the samples and the targets, and then shuffle them. So basically we take in the index. Then we shuffle these keys. Now this is essentially the new order of the indexes which we can then apply by doing. This tells NumPy to return values of a given indexes as we would normally index NumPy arrays, but we're using a variable that keeps a list of randomly ordered indexes. Then we can check a slice. Okay, then they seems to be shuffled. We can check individual samples by gear or shape. We can either check, okay, class is short. We might check a few more manual to ensure data as expected. If the model does not train or appears to be misbehaving, you'll want to double check how you preprocess your data. Batches. Okay, this is okay. So what will we do? We'll need to implement the batches. That's the interesting part. And then we go to, okay, so we need shuffling. I think I need a shuffling here, right? And probably we need to do shuffling before returning. So for example, we have the dense result data, result labels, and then we'll need a copy of them. And then we will, well, the first thing I need to generate a range, and I guess the range, so I guess there is no way to in range. What I want to do, I want to generate an index range, right? Okay, so probably I will need to do this here. Func make range. So we will have the len as int, and we will return and we'll return array of ints. So len. So what do? We have the values that is make of int and the len, right? And then we return values. And basically, what do I need? I from 0, I less than len. Okay, and what we do, we have the values equal to I. That's it, right? Okay, then the question, do we have a shuffle? And pseudo randomize another elements. So it's on the rand. Let me take a look. Shuffle this one. Okay, then for example, by shuffled, we take the int and we return int. Values. Basically, shuffled, we make int len of the values, right? Then what we do? So then we copy destination, source values, and then we rand shuffle len shuffled, and then return so shuffled I shuffled j equal to shuffled j shuffled I, and return okay. And that means then right now we can do this shuffled indexes equals to shuffled make range images count. Print couple indexes. Oh. Okay. Okay. So then what we need to do, I'm going to create temp results data, and that is math copy of results data. And then we have temp results labels, and that is then copy of results labels, right? And then what we do? Okay, then for I equal to range, it's actually I to range shuffled indexes. So we have the index, and that means results data set set row I, and in this case temp results data this, and then the result labels set I0, and I need to think, maybe I don't need the intermediate dense, but okay. Temp result data, right, I0. No, temp okay. At okay 10 0. Why? Okay. Let's take a look. So basically right now it should run, and it should wait. We have 0. Then I mean, I should run it several times, and it should return me different values several times, right? Minus 96. Okay. So it's actually different indexes. So maybe it was the coincidence. Set row. Will the dense copy make the full copy? Newly allocated copy. Okay. Okay, let's. No, I need to run it multiple times. I mean, if it will return me something different from 0, but it's not. Okay, so it looks like it's not shuffled. Okay, maybe I actually just need this one. Shuffled indexes. And so then ID dx is actually equal to shuffled indexes I. And then here idx and idx, and that's it. So we choose the target index. Okay, 1. Okay, yeah, that's better. That works. So basically what we're doing, we have the data, we allocate the results arrays that I want to. I have the shuffled indexes, and then I just take in by the normal index, and then I insert it in the randomized index, and that's it. Okay, so that's it for today. I will and shuffle the data set, and that's it. I will continue tomorrow with batches. I think this is the most, yeah, I think this one will be big. So yeah, thank you for watching, and see you tomorrow. Bye bye.